Welcome to this video on how to determine the wavelength of laser light. This can be done using a diffraction grating or Young's double slit. I'll first show you how to do this using a diffraction grating, and we'll then show you how to do this using Young's double slit. So, as you can see, we have a simple setup. We have a laser, diffraction grating, and a screen on which to project our light onto. As shown in this video, you can see bright fringes. We have bright central fringe there, and then we have fringes going out either side. So we have our first order, second order, third order, and just on the edge there, fourth order. Now when using this setup, we want to use the maximum number of orders possible. This reduces the percentage uncertainty in our measurements. So there are two ways in which we can measure what we need to measure. Let's talk about what we need to measure first. So this is the equation for a diffraction grating. We have n is the number of orders, lambda is the wavelength of the light, d is the slit spacing, and theta is the angle between the central order, which is that one, and whichever order in question. So if it was the third order, 1, 2, 3, the angle between that one and that one. So first thing we need to do is calculate the slit spacing. On our diffraction grating, it usually says the number of lines per millimetre. This is not the slit spacing. To calculate the slit spacing, we will need to do 1 millimetre divided by the number of lines. So 1 millimetre divided by 80 in this instance. Once we've done this and worked this out, we now need to measure the angle. Two methods of doing this. Number one, using a protractor. So we will draw a line from our central order to our diffraction grating, and then draw a line from the third order to our diffraction grating, and measure the angle between those lines using the protractor. Or we can use a ruler, and we can use trigonometry. So if we know the distance between the screen and the distance between the central order and the third order, we get a right angle triangle and we can calculate the angle. Once we've done this, we can then use this equation, rearrange it. The number of orders would be 3, d would be 1 millimetre over 80, theta would be whatever we have measured or calculated, and then we can use that equation to work out lambda. This is the preferred method for determining the wavelength of laser light. As you will see in a moment from the Young's double slit, the slit spacing is much smaller, making the percentage uncertainty in measurements much greater. So if I replace my diffraction grating with a double slit, the first thing you should notice is those bright fringes are much closer together, to the point where on this video you can barely see them being separated. So what we have to do is move our screen much further away. So now you can see that the spacing between those fringes is now a bit bigger. In an ideal situation, I would put this screen even further away still, but as you can see, I've run out of desk. So we now need to use this equation. Lambda, the wavelength, equals A, the slit spacing, times delta y, that is the fringe spacing, the spacing between two bright fringes, divided by the distance, capital D, between the slits and the screen. When doing this experiment, to reduce the percentage uncertainty, the best thing to do is measure the distance across multiple fringes. So for instance, we could do from there across to there, and divide by the number of fringes to get the fringe spacing. The slit spacing, we'd either need to measure using vernier calipers, or if the manufacturers were kind enough, they would have told us. In this case, they have not. Once we've made our measurements, the distance between the screen and the slits, the fringe spacing, the slit spacing, we can then determine the wavelength using that formula. Thank you very much.